Our calculator is programmed to find the test statistic and the p-value very nicely and easily for us, but we just have to do some decision making in order to make that happen. One more time, we've got the null hypothesis p is equal to 0.7. The alternative hypothesis p is greater than 0.7. And p hat in this case is equal to 112 over 1.52 or 0.74. Is that enough evidence? So we hit stats. Let me put this thing up so you can see what I'm hitting. If we hit stat and we go way over here, we'll get to tests. Notice that the top is the z-test, the next is the t-test. There's a 2 sample, but I only had 1 sample here. But there's a 1 proportion z-test. We go over here and we look. Since this is about the proportion, since these hypotheses have p in them, I'm going to use the proportion z-test. If this hypothesis was about mu, and I knew the standard deviation, I would use the z-test. If this hypothesis was about mu and I did not know the standard deviation, I would use the t-test. So for this chapter at least, right now, we're dealing either with the z-test, the t-test, or the 1 proportion z-test. In this case, we're using the 1 proportion z-test. And it says, okay, what is your null hypothesis? I say my null hypothesis is that p is equal to 0.7. It says, tell me about the evidence that you gathered. I got 112 yeses and 152, oopsie, try that again, 152 trials. And then it asks me, well, what's your alternative hypothesis? Is the alternative hypothesis is that p is not equal to 0.7, that p is less than 0.7, or that p is greater than 0.7? Since this guy is pointing to the right, we have a right-tailed test, and we're going to click on this one over here. Now I'll go back over here and calculate it. Drawing it is kind of a pain in the butt. And immediately it comes up with a z-score. It comes up with a p-value. And the z-score is the test statistic. The p is the p-value. So our p-value is 16. Which is greater than alpha. Remember, if you remember, alpha was equal to 5%. So once again, we're going to fail to reject it. Another thing to look at is the test statistic. The test statistic is 0.99. And remember, our the critical value was 1.645. Now you might remember that when we calculated our test statistic ourselves, we got something a little bit bigger than 1.0 something. That's because of round off. Because when we put this into our calculator, when we put this into this test, it got exactly this. When we calculated the z-score ourselves, we used this instead. That's not a big deal. I will either, in every case, it'll either be clearly a reject or clearly a fail to reject. And it doesn't matter whether you choose this as your test statistic or this as your test statistic. In both cases, we're going to fail to reject the null hypothesis here. So that's how you use your calculator. We'll practice some more with that with X bar.